Hello, this is Professor Zigman again for CTS560 Online. And what I'd like to do now is show you some ways of looking through the text of a Gaussian output file to get the information that's contained in that file. There's a lot of different pieces of information. Often we're just looking for one or two. And so let me show you how to search through this file to look for particular strings that will indicate the location of relevant data. So let me look through this directory of mine where I've done these carboxylic acid calculations and just pick one of the log files to look at. So how about the CHOOH_321G.log. Alright, so I highlighted that text, and then using the middle mouse button I clicked in order to paste it on the command line. M is the alias that I use for the more command, which you probably just type out. And so it will allow me to look through this file one page at a time, but I'm going to expand the window just a little bit so that I won't have to hit the spacebar so many times to page through the file. So this is a typical Gaussian output file. There's information. Now I can use the enter key to just go a few lines at a time. The information that shows the keyword line, and then also that gives information about the input geometry of the molecule right here. And then as we page through it, we see the different cycles that are used in solving the Schrödinger equation. And finally, after a number of these cycles, whoops, I went a little too far, but after a number of these cycles, then if I scroll back up a page or two, the SCF done, that gives us the energy of the molecule for this very first input geometry. And then the program is going to cycle through by calculating the forces, moving the atoms to different positions, recalculating the energy, and hopefully reaching an optimized geometry where the forces are all very, very close to zero. But what if I want to search through this file for different pieces of information? So let's assume I've done this geometry optimization plus a frequency calculation, and I want to have a very quick way, looking at this file, of finding the frequencies. So in Linux, the way that you do a search is you type a slash, and you can see now at the bottom of the screen my cursor is down here, the slash, and whatever string I want to find, FREQ, this will find the next occurrence of this string in the file. So if I hit return, somewhere on this page the word freak is found, and it doesn't distinguish case. So here it is. It's after the geometry optimization is done, when the frequency calculation is beginning. Now if I want to find that string again, instead of having to type /freak again, I can just hit the N button for next, and that will give me the next occurrence. And the next occurrence right here is on a page that shows the first of the frequencies, the vibrational frequencies that are being calculated. So this is a quick way to cut to the chase and find these frequencies to check to see whether they're all positive. Because we know in order to have an equilibrium, a stable equilibrium molecule, all of the vibrational frequencies have to be positive. If one or more of them are imaginary, it will show up in this file as a negative frequency, and then we'll know that we don't have a stable molecule and that we've got to perform the optimization all over again. So that's one thing that it might be useful to find. So I'm just going to Control C out of this. The up arrow in Linux repeats the previous command, and so I'll just do this again. Let's say that instead of just the frequencies, I wanted to know what the enthalpy of this molecule is at room temperature. And this week's assignment talks about how that's a quantity that you need to extract from the output file. So I'm going to type slash, and I'm going to go type thermo, because there is a keyword, thermochemistry, which is in the frequency part of the calculation, that then gives the important energies that I need in order to complete this week's assignment, to include the effects of temperature on the vibrational energy of the molecule. So under thermochemistry, there's the 0-point correction, which is the vibrational energy at zero temperature, and then there are various thermal corrections as well. And so what we have is a thermal correction to the energy at 298, but then the enthalpy, which is related to the energy but slightly different, the thermal correction to the enthalpy is here, And so what now appears down a little further is the sum of the electronic and thermal enthalpies. This quantity right here is the one that I want because it will give me the enthalpy, which now includes the electronic energy and the vibrational energies of the molecules at room temperature at 298 Kelvin. See the temperature is given up here. And that's what I want. That's what we call in the homework assignment the H, or the enthalpy for this molecule. So that's where to find it in this molecule, in this output file. Now, there are often cases where instead of simply looking page by page through the file, I want to automatically extract every occurrence of a particular string. And so the grep command is very useful in Unix to do this. And I'm going to put the string I'm looking for in quotes. And so here, let me look at a string. Don't know how useful this will be, but the string freak. So what this tells Linux to do is look at this file and display every line in this file that has the string freak appearing in it. So if I hit return for that file, I will get every line that has freak in it. So right there. There only apparently are 1, 2, 3, 4, 5 lines that have that word in them. So that's not very useful. But let me show you something that is useful. If I use the grep command and I take capital E left parenthesis, okay, and then I again CHOOH _ 321G.log. If I do this, what it will give me is each of the energies that are calculated for the different steps, the different geometries that lead to the final optimized geometry. And so this can be very useful if I want to see how those energies are changing from one step to the next until I finally get to the last one, and you can see that the final energy appears twice. The second to last time it appears, that's at the part of the calculation where the optimization is finished, and then the very last occurrence is when the frequency calculation is done. It recalculates that energy. That's just the standard way that Gaussian does these things. So we have that same energy twice. So grep is a very powerful command for extracting pieces from a file, lines from a file that have a particular string appearing in them. So these are the kinds of things that you learn after playing around with Unix for a while, or Linux in this case, and for file manipulation. And hopefully this kind of exercise is helpful to you as you're looking through output files and trying to get important information. One more thing I'll just show you. If I more this file, sometimes I want to look at charges, and if I just type CHARGES, then I see the Mulliken atomic charges. The first occurrence of this in the file is for the initial geometry, and then if I hit N for the next occurrence of it, you can see it's much later on, and this now corresponds to the charges for the atoms at the final optimized equilibrium geometry. So that's something that's useful to extract from the files. And you already know how to use Gauss view to find some of these quantities, but sometimes you want more detail than is available just through Gauss view. And so it can be helpful to go page by page through the file and look for additional information. I hope this helps.